Welcome to this lecture on finite element analysis, focusing on two-dimensional structural analysis using ANSYS Workbench. This session is presented by Professor Dr. Mohammed Al-Hazmi. Throughout this lecture, we will explore how to apply the finite element method to analyze 2D structures, such as a combination wrench, using ANSYS Workbench, a powerful engineering simulation tool. Problem description. In this session, we will analyze a stainless steel combination wrench. This tool, with a thickness of 3 mm, is subject to a distributed load. The goal is to determine the maximum deformation and von Mises stress distribution under specified boundary conditions. The hexagon end of the wrench is fully fixed, and a pressure of 2 MPa is applied. All units are in millimeters. Launch ANSYS Workbench to begin. Launch the ANSYS Workbench environment and save the project as wrench. This will be the workspace for our structural analysis. Create static structural analysis. In the toolbox, drag the static structural system into the project schematic. This sets up a new environment for linear static structural analysis. Add a new material. Double-click the engineering data cell. Select engineering data sources and choose general materials. Add the desired material, such as aluminum alloy, or modify the list to include stainless steel. Launch Design Modeler. Open the Design Modeler. Ensure that Surface Bodies is selected under Properties and that the analysis type is set to 2D. Select millimeter as the unit system. Create the geometry sketch. Create the geometry in the Z-plane using basic shapes. Begin with a rectangle, define its dimensions, then add circular holes, and define fillet radii as required. Trim unnecessary lines and arcs to clean the sketch. Create surface body. Switch to the Modeling tab. Use surfaces from sketches to generate a surface from your sketch. Set thickness mode to user-defined and assign a thickness of 3 mm. Exit the Design Modeler. Launch the model. Double-click the model cell to launch the mechanical interface. Choose plane stress as the 2D behavior and assign stainless steel as the material. Generate the mesh. Right-click on Mesh in the tree outline. Insert a method and sizing. Assign an element size of 1.5 mm and generate the mesh for the surface body. Apply boundary conditions. Insert a fixed support and apply it to all 6 sides of the hexagonal end. Use edge selection tools to include all relevant edges in the constraint. Apply loads. Insert a pressure load. Apply it to the appropriate edges of the geometry. Set the magnitude to 2 million pascals, or 2 megapascals. Use vector definition to specify direction. Retrieve the solution. Insert results for total deformation and equivalent stress. Solve the model by right-clicking on the solution folder and selecting Solve. Once completed, review the results. Result, deformation. The visual result shows the total deformation of the wrench under the applied pressure and constraints. Equivalent stress. Here we observe the von Mises stress distribution across the wrench. This highlights the regions of maximum stress concentration. Thank you for following this tutorial. This concludes our lecture on 2D structural analysis using the finite element analysis in ANSYS Workbench.